Now, a few reactions of alkanes are given. I'm going to write a few reactions. The first reaction, CH3, CH2, CH2, CH3 in presence of aluminium trichloride and HCl. Now this compound becomes CH3, CH, CH3, CH3. And this reaction is called isomerism. See, a reaction is given and the name of the reaction is given. You have to identify which is given the wrong name. See the B option, C6H14 at 773 Kelvin, it becomes C4H8 and C2H6. The name that is given for this reaction is pyrolysis. Option C, methane plus oxygen giving on heating carbon dioxide and water. The name given is controlled oxidation. And the fourth option given is methane plus nitric acid at 400 degrees centigrade, nitromethane. And this reaction is called a nitration. Now we have to know every detail of every reaction. The first one, see, look at the molecular formula. It is a C4H10. Look here, it is also C4H10. So both the compounds are having the same molecular formula, but their structures are different. Or two different compounds having the same molecular formula, they are called isomers. So the reaction that is given here is isomerism. That is correct. Pyro means heat. Lysis means to break. So on the application of heat, a big compound is broken into smaller compounds. So 6-carbon containing compound is now broken into 2 pieces of compounds containing 4 carbons and 2 carbons respectively. So this name is also correct. It is pyrolysis. On the application of heat, a compound is broken down. And the third one is methane. It reacts with oxygen to form carbon dioxide and water. There is a complete change. All the methane molecules are burnt into carbon dioxide and water molecule. So this is not a controlled oxidation. It is a complete oxidation. Complete oxidation. So this one is wrong. And methane, when it reacts with nitric acid at elevated temperature, nitromethane is formed. It is called a nitration. So here option C is the wrong one because it is not a controlled oxidation. It is a complete oxidation. So all other names are correct. Here you have to understand what is isomerism, what is pyrolysis, what is nitration, and what is oxidation. I suppose you understand things. The alkene that exhibits geometrical isomerism is. What is geometrical isomerism? Geometrical isomerism means It is found in the chemical compounds containing C double bond C. In the C double bond C, this is called cis isomer. This is called trans isomer. On the side of A, B is found. On the side of A, B is found. Similar groups are found on the same side. So this is called a cis isomer and this is called a trans isomer. Such kinds of isomers are called a geometrical isomer. Now 4 hydrocarbons are given and you are asked to identify which will give geometrical isomerism. A, propene. B, 2-methyl propene. C, 2-butene. D, 2-methyl 2-butene. 2-methyl 2-butene. So as I've already told you, first write the structural formulas. Propene. So CH3, CH, double bond CH2. So if you write this in the geometrical isomeric form, so C double bond C, in this carbon, both the sides H hydrogens are present. And here, 1 hydrogen and 1 methyl group are present. So even if you interchange these two groups, this will not lead to geometrical isomerism. So the first is not going to give geometrical isomerism. Second one, 2-methyl propene. So same propene, but now on the second carbon. So this carbon, 1, 2, on the second carbon, another methyl group is attached, and then double bond, and then CH2. So if you write it in the geometrical isomeric form, C double bond C, on this carbon, 2 hydrogens are found. On this carbon, 2 methyl groups are found. So this will not lead to geometrical isomerism. So second is also not the correct option. You look at the fourth one, 2-methyl 2-butene. 2-butene means C, 4 carbons. In between second and third carbon double bond is found. And then 2-methyl, 1, 2, 2-methyl. So 2-butene, 1, 2, 3. Here is one H and H3. 1, 2, 3. Sorry, this H is not there. So here 1, 2, CH3. If you write the compound in the cis-trans form, this side 2 methyl groups, this side 1 methyl group and 1 hydrogen. Even this will not give cis-trans isomerism. So this is also not the correct option. If you take 2-butene, so C double bond C, one side 1 hydrogen and 1 methyl group, and the other side 1 hydrogen and 1 methyl group. Now this becomes a trans form, and it can also exist in the, this becomes the cis form, and this can also exist in the trans form like this. This side CH3 and H. Therefore, the third option is the one which can exhibit geometrical isomerism. How many geometrical isomers are possible for the given compound? A compound is given CH3, CH, double bond, CH, single bond, CH, double bond, CH single bond, C2H5. The question asked is, how many geometrical isomers are possible for this compound? You have to identify the number of geometrical isomers possible. So I'm going to write this compound in the geometrical isomeric form. See here, C double bond C. On one side hydrogen, on the other side C. Again a double bond comes, C, H, C2H5, this side one H, and this side a H and CH3. So this is how the compound has to be written. Now, if you consider this entire group as one substitution, now here two isomers are possible because this can be either here or that side. But for this carbon, if you consider this entire group as a single unit, then two forms are possible. So this two, that's two, that two. So 2 into 2, 4. So 4 isomeric forms are possible for this compound. Which of the following compounds will show cis-trans isomerism? As usual, this is what we have already seen. 4 compounds are given A, CH3 twice, C, double bond CH, C2H5, B, H2C, double bond C, Cl2, C, CH3HC, double bond C, ClCH3, D, HClC, double bond CH2. First, you write the structural formula for all these compounds. Look here, I'm going to write the compound A in this cis-trans form, C double bond C. So, one hydrogen and one ethyl group. On the other side, 2 methyl groups are present. So this is compound A. So this cannot give geometrical isomers. Compound B, C double bond C, on one side 2 chlorines, on the other side 2 hydrogens. You cannot interchange the groups like this, just you have to change here and there. So this can also not give cis-trans isomers. And the third compound, C double bond C, one side chlorine and then methyl group, on the other side methyl group and hydrogen. So this can give cis-trans isomers because if the methyl group goes there, identical groups are opposite. So this will give you cis-trans isomerism. The fourth compound, C double bond C, so this is CH2, H, Cl. So this can also not give cis-trans isomerism. So the correct answer is C. So the compound C alone is able to give cis-trans isomers. So 2-bromopentene, when it is treated with alcoholic KOH, either the hydrogen from this beta or this beta can be eliminated in the form of HBr, but this is more favored. Therefore, the major product will be this one, 1, 2, 3, 4, 5, pent-2-ene. But pent-1-ene is a minor product. The name of the reaction is beta elimination. What is the order of reactivity? What is the order of reactivity of hydrogen atoms? Order of reactivity of hydrogen atoms. Order of reactivity of hydrogen atoms. Attached to carbon atom in an alkene, a double bond compound. What is the order of reactivity? Order of reactivity is, it is a direct answer question. Order of activity is tertiary, the highest, then the secondary, then the primary. Because inductive effect of alkyl groups increases the polarity of CX bond. Inductive effect will increase the polarity of CX bond. CX means the bond between carbon and halogen. Now, 3 compounds are given. CH3, CH2, CH2Br, CH3, CH, CH2Br. Third compound is CH3, CH2, CHBr, CH3. So these 3 alkyl halides are given. If they undergo beta elimination, when they are treated with alcoholic AOH, they will undergo beta elimination. What will be the reactivity order? That is the question asked. What will be the reactivity order? So look here. Watch closely. This is primary. And this is also primary. But this is secondary. We have already seen the tertiary, the rate will be the highest. And then secondary, and then primary. So if I say this is the first compound and this is the second one, this is the third one, the reactivity of the third one will be the highest. Now, the first and second compounds are primary. Among them, which will be faster or which will react faster or which will undergo a faster beta elimination? The second one. Because even though it is also primary, another methyl group is attached here. So the inductive effect of both methyl groups and then they carried over here. But here it is a straight line compound. Therefore, here the polarity will be more than that of here. Therefore, the reactivity order will be the third will be the fastest, and next to that, the second, and the least one is the first one. The ease of dehydrohalogenation. Dehydrohalogenation halogenation. Dehydrohalogenation for different halogens will be in the order. 4 different orders are given. You have to identify the correct order. I minus, Br minus, Cl minus, Br minus, I minus, Cl minus, Cl minus, Br minus, I minus, I minus, Cl minus, and then Br minus. The correct order, or actually the question is the ease of dehydrohalogenation. The correct order is the first one. Because I minus dehydrohalogenation will take place much easily in the form of HI. Dehydrohalogenation in the form of HBr will be the next one. Dehydrohalogenation in the form of HCl will be the least one. So the order is this. Very interesting one. What are the products of dehydrohalogenation? 4 products are given. Dehydrohalogenation of 2-iodopentane. 2-iodopentane. See, look at the options. Options are beautifully given. A, 2-pentene as a major product, 1-pentene as the minor product. Option B, 1-pentene as the major product, 2-pentene as the minor product. Option C, 2-pentene 50%, 1-pentene 50%, and option D, none of these actually. None of this should not be given, but in the book it is given, none of this. You first try to write the equation. See, 2-iodopentene, so 5 carbons, 3, 4, 5. In the second carbon, iodine is attached. So CH3, CH, CH2, CH2, CH3. So this compound undergoes dehydrohalogenation in the presence of alcoholic KOH. So what will happen? So this is the alpha carbon. This is the beta carbon. This is the beta carbon. So it is going to undergo beta elimination. So if the terminal beta elimination takes place, the product formed will be CH3, CH2, CH2, CH double bond CH2. If this beta hydrogen is lost, it will be CH3, CH2, CH double bond CH single bond CH3. I've already told you this is more favored than this. Therefore, this will be the major product and this will be the minor product. So major product will be 1, 2, 3, 4, 5. It is 2-pentene. Minor product will be 1-pentene. So the option A is the correct one. So